Welcome to this session where we are dealing with the trigonometric identities. Okay, so I'm going to explain how we come up with the identities, and then later we are going to work out some examples. Okay, so if you have say you have a triangle, this triangle here, and it is triangle, this is C, so triangle ABC. Okay, based on Pythagoras theorem, we know from Pythagoras theorem that a squared plus b squared should give us c squared. Okay, so that is just the basic Pythagoras theorem. Okay, now I want us to divide all through by c squared. If we divide all through by c squared, we will now have a squared over c squared plus b squared over c squared is equals to 1. Because c squared and c squared have cancelled, now we have 1. Okay, you remember now from laws of indices. From laws of indices, we will have that being a over c squared plus b over c squared is equals to 1. Okay, so let's hold these. Let's pause it for a moment. Let's go back to trigonometric ratios now. Say if this was our theta now, if this is theta, remember this is a right angle triangle. So if that is our theta, how do we find cos theta? Yeah, or sin theta? Sin theta is given by opposite over hypotenuse, which in our case, opposite will be A, hypotenuse is C, so A over C. Okay, and cos theta is given by adjacent over hypotenuse. Adjacent over hypotenuse. In our case, our adjacent is here. Adjacent is B. This is the opposite. This is the hypotenuse. So adjacent is B. So we'll have B over C. Okay. So that's be B over C. Now, if you check here, we have A over C squared. And now we can see that A over C is sin theta. In the second part, we have B over C squared. And now we see that B over C is cos theta. That means that we can rewrite this so that this equation now becomes sine, it is squared now, sine squared theta. Remember, you square the sine, not the theta. Theta is an angle, so you don't square the angle. So sine squared theta plus cos squared theta is equals to 1. Or as I always like rewriting it, I start with the cos. So let me start with cos. So we'll have cos squared theta plus sine squared theta is equals to 1. Okay, this here is called the fundamental trigonometric identity. It is very important because we will use it to derive the other trig identities. So you shouldn't forget this one. It is the fundamental trig identity. Okay, so now you have the fundamental trig identity. So how do you get the other identities? Okay, so for one, let me just note it here that we divide all through. We divide all through by cos squared theta. Okay, so let's do that. If we divide all through by cos squared theta, we are going to have cos squared theta over cos squared theta plus sine squared theta over cos squared theta is equals to 1 over cos squared theta. Okay, of course we can see that this will be 1. Okay, sine over cos, we already know that that's a tan. So sine theta over cos theta is tan theta, but now they are squared. So we are going to have 1 plus tan squared theta. I hope you see how that is coming about, because we have a sine over cos, sine squared theta over cos squared theta. And sine theta over cos theta is tan theta. Only that this time they are squared. So we have sine squared over cos squared to give us tan squared theta. Okay, now we have 1 over cos theta. What is 1 over cos theta? We already know, cos squared theta. We already know what cos theta is. 1 over cos theta, we know what it is. Yeah. 1 over cos theta is sec theta. Only this time it is cos squared. So we are going to have sec squared theta. Sec squared theta. And this becomes our second trigonometric identity. Okay? Okay. So now we want to get our third trig identity. What do? We divide all through by sine squared theta. We are dividing the fundamental trig identity. Remember, this here, this here is the fundamental trig identity. We said it is the fundamental trig identity. The fundamental trig identity, trigonometric. Okay? So, to get this is the fundamental. To get the first one, we have divided the fundamental trig identity by cos squared theta. Now, to get the second one, we are dividing the fundamental trig identity again, but now we are dividing it by sine squared theta. So we will have cos squared theta over sine squared theta plus sine squared theta over sine squared theta, giving us 1 over sine squared theta. Okay? And of course, sine over sine, so this one will give us 1. Now, cos squared theta over sine squared theta, that is the inverse of sine squared theta over cos squared theta, or the reciprocal. So, if sine squared theta over cos squared theta gave us tan squared theta, it means that sine squared theta over cos squared theta is 1 over tan. Okay? Or otherwise, that is now cot theta. So we'll have cot squared theta plus 1. Now, 1 over sine squared is, or 1 over sine is cosec. This time it is squared, so we have cosec squared theta. Cosec squared theta. And that becomes our third trigonometric identity. That's our third trigonometric identity. Okay? So let me just... That's our third trig identity. So there we have them. We have our first, second, and third trigonometric identity. I want us to see how we can use them in examples, okay? So here's our example 1. You have been asked to demonstrate the validity of the identity below. So this is what we want to demonstrate. What this means is we either have to solve the left hand side, this left hand side, to confirm if it is equal to the right hand side, or we have to solve the right hand side to confirm or to validate that it is the same as the left hand side. Now, I always prefer working with a side that looks complicated, because it has many things to be worked with. It has many things to simplify. For instance, I can already see how I can simplify this left hand side. This right hand side I might have to think so much, but this the right hand side, the left hand side, I can see what to do already. For instance, I see that I have two fractions, so I can find the LCM. Okay, so let's work that. So let's find the LCM. So I will have my LCM being 1 minus cos theta 1 plus cos theta. So that there is my LCM. Now 1 minus cos theta goes here, 1 plus cos theta times 1 plus cos theta times 1 is 1 plus cos theta. So I will have 1 plus cos theta. Okay, let me put brackets first, plus, okay, we are back here. 1 plus cos theta goes here, 1 minus cos theta times 1 minus cos theta times 1, we have 1 minus cos theta. So 1 minus cos theta. Okay, now we can simplify this further. Okay, so if I simplify it further, or if I open the brackets, let me actually open the brackets. If I open the brackets, I will have 1 plus cos theta plus 1 minus cos theta, all these over, so 1 times 1, I have 1. Okay, 1 times cos theta, positive cos theta, so plus cos theta. Okay, negative cos theta times 1, negative cos theta. Okay, negative cos theta times cos theta, negative cos squared theta, negative cos squared theta. Okay, I can simplify this further. I see how I can simplify it further. Okay, so when you look at the numerator, I have cos theta, and this is minus cos theta. So this will give me 0. 1 plus 1 will give me 2. The denominator, cos theta minus cos theta, this will give me 0. So I'll be left with 1 minus cos squared theta. Okay, let me write that down now. So at the numerator, I'm going to have 2 over, at the denominator, I'm going to have 1 minus cos squared theta. Yeah, I already see it coming up nicely. Okay, now for the numerator, we are done with the numerator. For the denominator, we have 1 minus cos squared theta. Now, this is an identity. Remember, from our fundamental trig identity, that stated that, let me just put it as a side note. Our fundamental trig identities, we have that cos squared theta plus sine squared theta is 1. And now, in this denominator, we have 1 minus cos squared theta. So look at this. Sine squared theta is 1 minus cos squared theta, just from the fundamental trig identity. So we see that this denominator, 1 minus cos squared theta, we can replace its value with sine squared theta. So that I will have 2 over sine squared theta, or that is the same as 2 times 1 over sine squared theta. But I know what sine squared theta is. Sine squared theta is the same as cosec squared theta. So this ultimately becomes 2 cosec squared theta. Okay? That is our final answer. Hence, proven. Hence, proven, because this answer, we have simplified it to a point. Now we have validated that this was the same as this because this answer is what we have gotten here. Okay? So hence, proven. Okay. Let us check another example. Let's check another example. So here's our example 2. Okay, so example 2 says show that tan theta plus cot theta is equals to sec theta cosec theta. Okay, that's what we have. Let's get down to business. Now, I want to work with the left hand side again because I already see it has things that I can work with. Yeah, but you could even start from the right hand side, it's okay. Yeah. So let's start with the left hand side. So we know that tan theta is the same as sine theta over cos theta. Okay. Why am I doing that? Because I can see that this right hand side, I can see that the right hand side has sec theta. I know that sec theta is 1 over cos theta. I know that cosec theta is 1 over sin theta. So I want to try and make these or change these into sine and cosine forms. Okay? Because I can see 1 over cos, 1 over sine this other side. Okay? Let's do that. So tan theta solution. So to my solution, tan theta is the same as sin theta over cos theta plus cot theta is the same as cos theta over sin theta. Okay, that's a good start. What do we do next? Next we can find the LCM. Okay, to find the LCM, we are going to have cos theta sin theta. That's our LCM. Okay, cos theta goes here, sin theta times sin theta, we have sine squared theta. So sine squared theta plus sin theta goes here, cos theta times cos theta will give us cos squared theta. So cos squared theta. Okay, I already see something beautiful there. I don't know if you can see it. Let me give you a few seconds to just look at it, see if you can, if you see something special there. Okay, I see that the numerator gives me the fundamental trig identity. Remember the fundamental trig identity? We said that this is the fundamental trig identity. Cos squared theta plus sine squared theta is equals to 1. And this is the exact thing that we have on in the numerator. So it means that they will now change to, I'll replace the sine squared theta plus cos squared theta with 1, so that I will have 1 over cos theta sine theta. Okay, and that is the same as 1 over cos theta times 1 over sine theta. We know that 1 over cos theta is the reciprocal of cos theta. We know that is sine theta. No, sorry, is sec theta. And 1 over sine theta is cosec theta. Therefore, my final answer will be sec theta cosec theta. And this is similar. We can see that this is similar to what we are given here. Okay, so hence proven. Okay, I hope you've already started understanding what's going on here. Yeah, because I want to do maybe one or two more examples. Let's do two more examples. Let's do two more examples so that we can understand it better. So let's go to example 3. Example 3. So here is our example 3. Demonstrate the validity of the identity below. We are given tan squared theta minus sine squared theta is equal to sine power 4 theta sec squared theta. So do I know what sine to power 4 is? Not really. Okay, maybe sine squared and then squared, but it is easier for me to work from the left hand side again. It has easier things to work with. Okay, and that's what I'm going to do. Okay, so let's get going. Solution. I know that tan squared theta is the same as sine squared theta over cos squared theta. So why am I doing that? Because I can see on the right hand side, I have sine, there's a sine there, there's a sec there. A sec means there's a 1 over cos somewhere. So I know there's a sine and there's a cos somewhere. So I want to transform all these into sines and cos. Okay, that's what I'm going to do. So tan squared theta is the same as sine squared theta over cos squared theta, okay, minus sine squared theta. Okay, so next, what do I do there? We can find the LCM. We can find the LCM so that my LCM will be cos squared theta. Okay, yeah, that could work. I see two ways of doing it. Let's just work with this one that I've already started working with. So cos squared theta cos squared theta goes into cos squared theta. Cos squared theta goes into cos squared theta once. 1 times sine squared theta, we have sine squared theta. Okay, minus 1 goes into cos squared theta many times? Cos squared theta times sine squared theta, we have cos squared theta sine squared theta. So we'll have cos squared theta sine squared theta. Okay, I can factor out sine squared theta. Yes, I can factor sine squared theta. So if I factor sine squared theta, in the numerator I will have sine squared theta into 1 minus cos squared theta. Denominator still have cos squared theta. Okay, realize that if I open the bracket, this will be sine squared theta times 1 will be sine squared theta, which is here. Sine squared theta minus cos squared theta will be cos squared theta sine squared theta, which is here. So I've just factored out sine squared theta. But I know from the trigonometric fundamental trig identity, from fundamental trig identity, I know that cos squared theta plus sine squared theta is equals to 1. Therefore, sine squared theta is equals to 1 minus cos squared theta. What that means is that this cos 1 minus cos squared theta here it is, I can replace it with sine squared theta. Okay, let's do that. So I will have sine squared theta into sine squared theta over cos squared theta. That's the same as sine to power 4 theta. Yeah. Times 1 over cos squared theta. Again, we know, okay, this is times. We know that 1 over cos squared theta is sec squared theta. Therefore, my final answer will be sine to power 4 theta and sec squared theta. That is my final answer. And we can see that this final answer is the same. We have managed to simplify it to this form, okay? Hence proven, or hence demonstrated. We have proven it. Okay, let's check our final example, example 4. So here is our example 4. We have been asked to prove the identity given below. Okay, now let's get to business. Solution. So what do we do? I can see that the left hand side is almost similar to the right hand side. Okay, I don't have much to work with from both sides. Okay, something here. We can cross multiply them, because if I cross multiply them, I see somewhere I will have a cos squared theta that I can work with. Okay, so let's do that. If we cross multiply them, we will have 1 plus sine theta times 1 minus sine theta being equal to cos squared theta. Oh, this is a nice one. At least now I have a right hand side and a left hand side that I can work with. Okay, so let's open the brackets. If I open the brackets, 1 times 1 will give me 1. Okay. 1 times negative sine theta will give me negative sine theta. 1, not, sorry, sine theta times 1, I will have sine theta positive plus sine theta. And then sine theta times negative sine theta will give me negative sine squared theta. Negative sine squared theta. Okay. If I simplify this, I see I have, here I have minus sine plus sine. So this will be 0. I'll be left with 1 minus sine squared theta. So I have 1 minus sine squared theta. Okay. From the trigonometric fundamental trig identity, we have cos squared theta plus sine squared theta giving us 1. So that cos squared theta is equal to 1 minus sine squared theta. See, now I have this 1 minus sine squared theta, which is the same here. So I can replace this value with the cos squared theta. Okay, let me do that. So this will be cos squared theta is equals to, notice this other side, cos squared theta is equals to cos squared theta. Cos squared theta. So I've finally proven it. This is my answer. Okay, so hence proven. And that marks the end of our session on trigonometric identities. Thank you so much.